Hey everyone, I'm Gohar, a backend engineer on the Sigma DAI team. Today, I want to take you deep into the world of ST35, the unsung hero of dynamic ad insertion in broadcast and streaming workflows. If you're working in broadcasting, encoding, or OTT with SSI, chances are you've bumped into it. But what exactly is it? Why is it so cryptic looking? And how does it even work? Let's break it down piece by piece. First, what is SCTE-35? Technically, it's a standard published by the SCTE, that's the Society of Cable Telecommunications Engineers. In simple terms, it's a digital signal or marker inserted into video streams to signal downstream systems that an event is about to happen, like the start or end of an ad break, a program transition, or blackout zones. Think of it as a metadata queue that rides along the video stream, saying, hey, something's coming, only in a machine readable format. So, where does SCTE-35 fit in dynamic ad insertion? Great question. Imagine you're watching a live sports match, and at the perfect moment, boom, an ad comes in, then the stream continues smoothly. For that to work, there needs to be a trigger in the stream that says, insert ad here. That's the SCTE-35 queue. Without it, the downstream SSI, server-side ad insertion platform, would have no clue when to splice the ads in or out. It's the linchpin between the content and the monetization layer. Now, how does SCTE-35 actually travel in the stream? In traditional broadcast workflows, it's embedded inside MPG transport streams, carried as a PID, typically 0x0023. In OTT scenarios, it's usually preserved as part of the HLS or dash manifest, either carried in ID3 tags for HIS or event stream for MPEG dash. The key is, this queue needs to survive all the way from the broadcaster's encoder to the client-side SSI logic or wherever the splicing happens. Okay, let's get real. The SCTE-35 queue looks scary. It's binary. It's filled with hex. What are we even looking at? A typical SCTE-35 message starts with a header that includes things like the table ID, section length, and protocol version. After that, you'll find the actual splice command, like splice should insert, time signal, or splice null. Each command type comes with its own payload structure, and yeah, decoding it by hand is painful. That's why we use libraries like SCTE-35-decoder or services that expose clean JSON versions. Let's zoom in on the most common splice command, splice insert. This one is used when we want to indicate a specific event is starting or stopping, like the start of a commercial break. Inside it, there's a bunch of fields: event ID, splice event cancel indicator, out of network indicator, PTS time, and more. One important bit: PTS time is the time code where the event should take place based on the program clock reference, so it's extremely precise. Timing is everything. The PTS E time value isn't wall clock time, it's based on PTS, presentation and timestamp. And in MPEG-TS, one PTS unit equals 1/90,000th of a second. So, if the PTS tick hour time is 81 million, that's exactly 15 minutes into the stream. Your ad insertion platform needs to convert that precisely so that the ad plays at the right frame. Not too early, not too late. But splice, scheduled insert, isn't the whole story. Most modern SCTE-35 messages also include segmentation descriptors. These are optional data blocks that describe the type of event. Is it a program start, an ad pod, a promo? For example, segmentation type ID equals 0x10 means an ad start, and 0x14 is program start. Combined with segmentation event ID and duration, These descriptors help SSAI platforms and content distributors make smarter decisions. Let's walk through a real example. Say we receive a base 64 SCTE-35 payload, like FCPA IAP slash for IBF plus GX slash 4 RGF Fokibeki AO up era 8 goblikte equals. When decoded, we get a splice insert command with a PTSD time value of 90,000. That's exactly 1 second after PCR start. The segmentation type tells us it's an ad break. SSAI sees this and prepares to insert a pre-roll or mid-roll ad at the exact timestamp. Unless you enjoy hex math, you'll want some tooling. Tools like SCTE-35 Thrift, SCTE-35JS, or even FNPIC with certain flags can help you extract and decode SCTE-35 queues from TS files. Some encoder vendors also expose SCTE-35 events as clean JSON APIs, which is a dream for backend devs like me. In OTT, the queue is often extracted at the packager level and converted to add metadata that SSAI uses. For example, in HLS, SCTE-35 might appear as a number sign EXTO ATCL SCTE-35 tag embedded in the manifest. The SSAI platform then reads that, decides which ad to insert, and stitches it in seamlessly, either in real-time live SSAI or during pre-processing VOD. Without that queue, the whole ad experience falls apart. Of course, it's not always clean. Some encoders don't preserve SCTE-35 properly. Others inject malformed signals. Or maybe the timing is off, which breaks the ad playback. Debugging SCTE-35 issues is a common headache. But once you get a feel for the format and use the right tools, it gets easier. Having logging at each stage of the workflow really helps, especially in SSAI, where milliseconds matter. Why does SCTE-35 matter? Because it's the glue between content and monetization. Without it, DAI wouldn't be possible, at least not reliably. Whether you're a broadcaster, an encoder engineer, or working on SSAI logic, understanding SCTE-35 gives you more control, more stability, and more revenue opportunities. Alright, that was a deep dive. I hope this helps demystify what SCTE-35 is, how it works, and how you can use it to make your streaming workflows more dynamic and profitable. If you want to dig deeper or see how we handle it at Sigma, feel free to reach out. Thanks for watching and happy splicing.